శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో NBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Good morning students, I am Harsha, Assistant Professor from the Department of EEE. I am going to deal the subject for 4th BTech first SEM students, and the subject name is Special Electrical Missions. Good morning students, in the previous session we have discussed about a permanent magnet motor characteristics. In this session we are going to learn a new topic about the effects of temperature on magnetic strength. I mean to say, we have different types of magnetic materials. So initially I have told you there are different types of magnetic materials like paramagnetic material, diamagnetic material, like that we have different types of magnetic materials. Let us learn the effects of the temperature on these magnetic materials. So let us see what are the different types of magnetic materials. My question is for you, what are the different types of magnetic materials? I have already shown you the graph. So year by year the magnetic materials are changing. So initially there is an aluminum, nickel, cobalt, now NdFeB, samarium, cobalt, like that we have different types of magnetic materials. So of all of these magnetic materials has a temperature. So what are whether these materials work on the different temperatures or not? So let us see in this session. So what is the effect of the temperature on the magnetic strength? So initially let me remind you what are the different types of magnetic materials. So there is an uranium, ceramic, nickel, alloy, cobalt, aluminum. So these are all different types of magnets. So ceramic, so composition of powered iron oxide and strontium carbonate. So ceramic is a mixture of the iron oxide and the carbonate, okay, and it is the most common magnet because it is cheap and easy to produce. So next one is alloy of technol, which is nothing but an alloy of titanium, cobalt, nickel and aluminum developed by the for the development of Philips for the loudspeakers. So we have different types of magnets. So we will use these magnets in our special electrical missions, especially for the purpose of permanent magnets. We have permanent AC motor, we have a permanent magnet DC motor, like this. Let us see how far these materials have these magnetic property, how long these magnetic materials have these temperature. If they lose the magnetism property on the effect of temperature, so then the magnetism property will changes, yes or no? This is the disadvantage. So let us see the effects of the temperature on the magnets. So these are the different types of magnets. Let me repeat you again: ceramic, alloy, cobalt, nickel, aluminum, like this. We have high magnetism property materials also. Now samarium cobalt, okay, samarium cobalt, NdFeB, like that we have different types of magnetic materials. So these magnetic materials has a temperature, yes or no? So it has to work on the temperature, it has to work on heat temperature, it has to work on cold temperature, like that. So how far these magnetic materials have the effects on let us see the effects of the temperature of the magnetic material. So how long they will stay, how long they will they will be strengthened, how long they will be strengthened. Let us see. So there is an injection model composition of various types of resin, magnetic powders. So there are complex shapes to manufacture these magnetic materials. Okay, so they should not lose, I mean to say how long they will work means, so they should not lose their magnetic strength, they should not lose their magnetic property. So if you take an electromagnet, you know electromagnet, a wire has thin coiled into one or more loops, so the electric flows through a wire. So whenever the supply is given to the whenever a AC supply or a DC supply is given to the a stator or a rotor, I mean to say whenever you give the supply to the winding, it gets excited and produces the magnetic field. So then you will get electromagnetic field, you will say electromagnetic induction, like that. Okay, so like this we have different types of, not only the material itself, not only the winding itself produce the magnetism property, the material itself, it also produces the magnetism property. So it has some residual. If you take any machine, AC machine or a DC machine, so not only the winding will produce the magnetic field, but also the material will also produce the magnetism field, magnetic field. So I mean to say each and every magnet has its residual magnetism property. So an electromagnet, you know electromagnet, a wire has a thin coil into one or two lobes, electric current flows through a wire causing a magnetic field to be generated. Commonly used in electric motors, you know, cranes and the medical equipments like MRI machines. Mostly the machines in missions we will use these magnetic field, yes or no? So if there is no magnetic field in a machine, you cannot operate your motor, yes or no? So like that. So the magnetism property plays a major role in electrical machines. So if you take any machine, AC machine or a DC machine or a special electrical machine, if you take any machine, these magnetic field plays a major role. Okay, so in these type of materials, what is the magnetic field strength? We have to know what is the magnetic field strength. So depending upon the strength of the material, it works. So whether these magnetic material works at different temperature or not, I mean to say our machine will be at heat temperature and hot temperature, our machine will be in cool temperature, yes or no? It should be worked at different temperatures. So now in the previous session you have observed that in the place of stator poles we have placed permanent magnets. So how far these permanent magnets will withstand on the motor? So in order to know that, you have to know about the temperature. If the temperature is changed on the magnetic material, so they will lose the magnetism property, so such that it has to maintain at different temperatures. So we have different types of materials, so in order to work these materials, it should be worked at different materials. If they lose their magnetism property, it will be useless now. So most of the machines in AC machine or a DC machine, so all these materials work with magnetic field only. So now we in special electrical machines, we are placing permanent magnets. So whenever you place these permanent magnets has dielectric strength or not. So whether these material will produce the magnetism property or not at different temperature. So many after some years or after some months, it will lose, whether it is losing its magnetism property or not, how far the magnetic field strength is maintained in the machine. So in order to know that, we have to know we have to work these magnetism permanent magnets at different temperatures. Okay, so like this we have different applications. We will use these permanent magnets. So let us see the temperature effects. So commonly uses, so what are the uses of magnets? So we will use these magnets at VHS tapes, audio tapes, floppy disks, hard disks, credit cards, television speakers, microphones, compasses. In all electrical machines we will use these permanent magnets. Okay, so I mean to say the material itself have some magnetism property. So that is in the sense residual magnetism property. The material itself has some magnetism property. Okay, so how far these magnets are have dielectric strength, I mean to say how far they will withstand. Let us see. So These purpose, what is the purpose? In order to measure this temperature, in order to know the temperature of the magnets, so there is some experiment. Let us see that experiment. In order to know the temperature, I mean to say how far it works on the room temperature, how far it works at the warm temperature. Let us see. So the purpose of the experiment is here. If the strength of the magnet would be altered when placed in temperature zones less than room temperature and warmer than the room temperature. So these magnets are measured at cold temperature and heat temperature. How far the field strength is maintained, how far they will withstand at different temperatures. Okay, so let us see. If the strength of the magnet would remain changed, if the magnetic strength is changed, then it loses its magnetism property, yes or no? So at different temperature it should be maintained. So if the strength of the magnet would remain changed when the magnetic return to the room temperature. So let us see. Null and alternative hypothesis. So what is the null means? What is meant by null? So the temperatures will not change, so it will maintain the magnetism property. So the temperature changes will not significantly affect the magnetic strength of the magnets. So it will not affect these magnetic strength. So at null condition, the temperatures will not change. So significantly it affects the magnetic strength of the material. So if the temperature changes, will not significantly affect the magnetic strength of the magnet. So another one is alternative. So at various temperature it will lose its magnetism property. So there is an effect of magnetic property. So there is an effect at different temperatures. So when it is run at different temperatures, these permanent magnets are placed at different conditions, different weather conditions. I mean to say different temperatures, they will lose its property. Okay. At null temperature, it affects the strength of the magnets. At alternative temperature, it affects the magnetic strength. So it significantly affects. So at null temperature, it will not affect the magnetic material, and at alternative temperature, it will affect the magnetic strength. Okay, let us see the strength of these materials at minus 80 degrees freezer, minus 20 degrees freezer. These are the measuring. So whenever these permanent magnets are placed on the mission, so these are measured at different temperatures. These are measured at different temperatures. I mean to say minus 80 degrees freezer, minus 20 degrees freezer, minus 4 degrees refrigerator, room at 20 degrees, and 45 degrees incubator, and 100% dry oving. So 30 ceramic magnets extra through RMS digital multimeter. So these are the measuring equipments in order to measure the magnetic strength of that material. So I mean to say, so whenever these materials are used in an electrical mission, these permanent magnets are used in electrical mission. So whether these magnets are significantly working or not, I mean to say significantly are withstanding or not. If it is not withstanding, they will lose their magnetism property. So in order to that, these permanent magnets are measured at different temperature, 80 degrees, 20 degrees, like that. So it will measure at different temperature, and they will check the details of the temperature, and they will check the magnetism property of that material. So if the temperature changes, whether it is losing the magnetism property or not, like that, they will discuss all these things, and I mean to say they will take the data and observe how far these magnets are withstanding whenever it is placed at different applications. So let us go for the next slide. So like this, they will be there is a measuring procedure. So the 30 magnets are labeled at 1 to 5 for six different temperature zones. The magnetic strength of each magnet was measured with voltmeter, and this magnetic strength will be measured through voltmeter, how far they are working. This is the formula for that. B is equal to 1000 into V naught minus V1 by K. So if the 5 magnets of each group are placed in the following, the 80 degrees freezer, 20 degrees, minus 80 degrees, minus 20, at cooling temperature it also measured at 4 degrees refrigerator. So at room temperature it will be measured at incubator at 45 degrees, drying oven 100 mm. So what I am going to say is here, these magnets are measured at different temperature. So by measuring like this, how far they are withstanding on that temperature, how far they are withstanding at temperature. So these are the by measuring at different temperatures, we are able to know that how far these magnetic materials are withstanding at different temperatures. So if it is in cool temperature, if it is in cool temperatures like minus 80 degrees or minus 20 degrees, how far they are withstanding. So whether they are losing the magnetism property or not, whether they are losing the magnetism property or whether they are not losing the magnetism property or not. So how far it is the magnetic material is withstanding at those temperatures. So this is about the effects of the temperature of the magnets, the effects of the temperature of the magnets. So whether there is an effect or not. So I have in the previous slide we have seen that at null temperature and what is the alternative. At null there is no effect, at alternative there is an effect. So in order to measuring all these effects, it should be measured at different tests has to be done on these magnetic material. So if you see that the temperature of each magnet was measured immediately after the magnets were removed from the environments. So these temperature of each magnets were measured immediately. Immediately it should be measured at different temperatures. I have already told you it should be measured at different temperature. It should be measured at different temperatures immediately. So after the magnets will be removed from the environments. Okay, so the magnetic strength of each magnet was measured immediately after the removal of the temperature zone. The data will be recorded whether it is working in the heat temperature or not, whether it is working on the cool temperature or not. So the magnets were allowed to return to the again 20 degree again it will be returned to the normal temperature, and how far they are working they will be measured. It will be measured, and the experiments has been done on the these magnets at 4 degrees and recording the magnetic strength. These are the magnetic materials these are the measuring equipment in order to measure those magnets. These are the at room temperature, at incubator, and recording the magnetic strength and drying oven 4 degrees Celsius. So what is the approximate result? So at north and south poles of these magnets in the 4 degrees refrigerator and 100 degrees drying oven, it will be significantly affected by the variation in the temperature when they were immediately removed from the temperature. So there is an effect, there is an light effect in the temperature of 4 degrees refrigeration and 100 degrees refrigeration. So this is one type of disadvantages by using these magnets on the mission. Okay, and north poles and south poles of the magnets is 45 degrees and incorporated at 100 degrees drying oven. So whether these magnets are working in the room temperature or not, like this, these magnets will be measured it in the 45 degrees incorporator and 100% drying it. Okay, so they were significantly affected when the magnets are returned to the room temperature. So this is the disadvantage. There is a temperature effect on these magnets. So there is limitations and extents, and there are two of the magnets stuck together, and this prevent maybe recording at their strengths, and they were taken out of the temperature zone, and it was unable to record the strength of the magnets while they were in varying at temperature zones. So it had I had to remove the record their strength, and they have to begin at 20 degrees Celsius. So in future I would be applied at cold temperature and warm temperature, trying different methods for heating and cooling the magnets such as dry ice or boiling water. So it should be measured at different temperatures. There will be limitations and extension. So, and from the entire scenario, what I am going to say you is that these magnetic materials are tested at different temperature levels. So whenever it is measured at different temperature levels, how far they are withstanding. So in our special electrical machine, there is a permanent magnet motor. In the stator, we will place a permanent magnets. How far they are withstanding. So whether they effectively it is giving the magnetism property or not. So if it is not effectively giving these magnetism property from the stator, so it is a disadvantages. So when there is no electromagnetic induction in the material, so your machine will not work properly. So in order to that, there is an effect of temperature on these permanent magnets. Okay, so there is an effect on the temperature magnets. So let us see the next slide. Last, we can say that there are different effects on the magnetic performance. So what are the factors that affect magnetic performance? I mean to say, what are the factors that affects these magnetic stability are time, temperature, change in reluctance, external magnetic field, radiation and vibration. So there are some effects on these magnetic performance. So there are some effects on these magnetic performance. So what are those effects? With respect to, it will change the effect of magnetic stability. So it will lose its magnetic stability. What is the magnetic stability that affects are the time, temperature, change in reluctance, external magnetic fields and radiation and vibration. Okay, these permanent magnets can produce extremely strong forces which holds the domains in the places within the magnet even after the exposure of the strong external magnetic fields. So there are strong magnetic field domains. So by these small magnetic domains and like that we have long I mean to say there are some magnetic domains in the magnetic material. So they will affect these magnetic domains and changes in the time, temperature, change in reluctance and external fields and radiation and vibration will occur on these magnetic material. So by this what I am going to say is these will changes these after magnetization, they will change immediately, the property will be changed immediately. So this is an according to time it will affect these magnetization property, so which is also called as a magnetic creep. So it will get fluctuated and it will not be operated properly, and this is the variation due to the number of unstable domains decreases. So the rare earth break I mean to say the rare earth magnets will less to experience this effect. So if the property has high magnetism property, so it will not lose it will not affect. So I mean to say it will not get affected at different temperature. If it loses its magnetism property, I mean to say if when it is worked at different temperatures, so then what are the factors will affect, what are the effects will occur on these permanent magnets. So what are the factors? I have already told you: the temperature, change in reluctance and external magnetic field, radiation and vibration. So whenever these factors will occur, these magnetism property, I mean to say these permanent magnets will lose their magnetism property after its magnetization. So there will be some fluctuations in the material. So whenever these fluctuations will come, they will these material will lose the magnetism property and get affected. The mission will be get affected. So let us see what are the losses in this magnetic material. So there are different losses. One is reversible loss, irreversible loss and metallurgical changes. So there are the temperature effects. I mean to say there are three main temperature effects. One is irreversible loss, another one is irreversible loss, another one is metallurgical changes. So these are the different effects which will fall into three categories: reversible, irreversible and metallurgical charges. So let us see the materials which are affected, and I mean to say B and H is affected on these by using these materials. You know B means magnetism, magnetic flux density, and H is the magnetic field intensity. So they will lose at these different temperatures. Neodymium is NdFeB. NdFeB is the highest magnetism property. So what is the temperature of the B is minus 0.11. It is very less, and the temperature effect is here at field intensity is minus 0.60, and the temperature of B and temperature of C at Curie temperatures. And samarium cobalt 0.03, and for the H 0.30, and aluminum nickel cobalt minus 0.02 and plus 0.01, and ferrite, so ferromagnetic material 0.18, minus 0.18 and plus 0.30. So these are the reversible temperature coefficients for B and H. So I have in the previous session I have told you about B and H. So B is the magnetic field intensity, I mean magnetic field density, and H is the magnetic field intensity. We have drawn the BH curve also. So these losses will that recovers the magnetic returns into this original temperature, and the reversible losses cannot eliminate this magnetic stabilization, and the reversible losses are at the reversible temperature coefficients at B and C. You can see these temperature. So if you use these high grade magnetic materials, then they will not lose the magnetism property. So why? Because these materials are tested at different temperatures. So for these there will be no reversible losses. So for example, the losses will vary at different temperatures. At linear temperature it increases. So for example, NDFE, you can see that minus 0.11. At reversible loss has 11% less magnetism. So reverse losses, if there is any reverse losses, you can see there is reverse losses here. So less magnetism flux at 120 degrees Celsius than at 20 degrees Celsius. So you can see this reversible temperature coefficients of B and H. And next one is irreversible losses. So these losses are defined at partial magnetization of the magnet and from exposure to high and low temperatures. I have already told you. At other demagnetization influences. So these losses are very recoverable, and these will not affect much effect on the magnetism property. So returns to the original value. These occurs at the magnets at temperature higher than maximum operating temperature. So whenever at operating at magnetic falls below the knee of the magnetization curve. And another one is magnetic changes at Curie temperature. At Curie temperature, so maximum working temperature of the different materials. So neodymium, so which is nothing but NdFeB again, and the temperature at C is Curie temperature and 310, and maximum temperature is 150. And samarium cobalt and Curie temperature is 750 and maximum temperature is 300. Elino is 860 and maximum temperature is 540, and ferrite is 460 and temperature maximum is 300. So let us see about these are the different temperatures at metallurgical changes. So whenever there is changes in the material, so these are the at Curie temperature level, at maximum temperature, these are the values for these materials. So these are extremely at high temperatures. They are tested at high temperatures. These are feasible at high temperatures. And this is also called as a magnetic Curie temperature also. So whenever a metallurgical change occurs, the magnetic properties are not recoverable. So when these materials are gone to the excess heat, so they will lose their magnetism property and it will not be recoverable. In some cases it will be recoverable. So these are the metallurgical changes will occur on the magnetism material. So at Curie temperature, the magnetic domains lose their locked positions, regain at a random orientation in the material at Curie temperature. So in order to eliminate these temperature effects, you have to take the magnetism material at which has high dielectric strength, which has high magnetism property. So you have to choose that magnetism. We have different magnets. Which magnet has high magnetism property? So it is I have already told you in disadvantages of these materials. These are very high cost. So it is very high cost equipment. If you take a permanent magnet DC motor, it is very cost equipment. So it is very costly in order to buy these motors. So it is very costly, and it should be maintained. The magnet should be cleaned at after the lifespan. It should be after there is some service. There will be some service. In order to that, you have to do the service and clean those magnets in order to without losing the magnetism property. If you doesn't maintain those magnets properly or properly clean, they will lose their magnetism property. Okay, so in order to that, you have to take high grade magnetism property. In permanent magnets, we have high grade magnetism property. So in order to that, we have seen that what are the temperature effects on these material. So in the permanent magnetic materials, in case if you use some type of materials like cobalt, elino, ferrite, so like that neodymium, so it should be tested at different temperature. On these temperatures, so what is the effect has been taken on these material. So that's why we have seen the temperature effect on these magnetic materials. Okay, so it will be very easy for you. So if this question is asked you like this, what are the temperature effects from the magnetic material? So you have to write these magnetic material will be tested at different temperatures. I mean to say samarium, cobalt, nickel, these magnetic materials are measured at different temperatures. So whenever it is measured at different temperature. What are the temperature effects on these material? So what are the losses? I mean to say, we have seen that reversible loss, so irreversible loss and metallurgical changes will occur on this material. So this is the one disadvantages in magnetic materials, and these permanent magnetic materials are very expensive at cost level. So depending upon the temperature effects of the magnetic materials, there are three types of losses. One is reversible loss, irreversible loss and metal allergic changes. Okay, thank you all. We will meet in the next session. Thank you.